So, after getting the value of negative 885.853, we should get the value naman of this point in our shear diagram. So, there is a more intricate solution to this one, pero padadaliin ko na lang yung buhay nyo. So, dapat kasi when it comes to the regular shear diagram, dapat pag may mga point load tayo, umaangat na lang, tama yan. Umaangat na lang dapat yan ng ganyan, tama naman, di ba? Pero for this one kasi, kailangan ini-spread kasi natin yung PU for this one. So, dapat yung PU natin is an equivalent uniformly distributed load. Pero, padadaliin ko na lang yung buhay nyo by providing this trick, So, sundan nyo na lang. For this point in this shear diagram, that value is equal to 902 minus the W, which is 303.026, multiplied by the tributary width na hanggang dito, So, that is 0.3 plus 5.6 plus 0.5, which is 6.4, plus the load of 1401. Para makuha natin yung value ng point na to. So, that is equal to 902 plus 1 plus 103.026. That is 363. Angat ko lang dito. 363. Wait lang. 363.634. Then, to close this one, that is just 363.634 minus 303.026 multiplied by 1.2. And that is equal to approximately 0. Pero 0 naman yun, syempre, kung nag-store lang tayo ng values. So, that is the shear diagram for this combined footing. So, ganun lang siya kadali construct. And ito na yung magiging values na gagamitin natin for solving all the problems with regard to the combined footing. So, unang pinapahanap sa atin is the value of the maximum factored moment that will be used in the design of the longitudinal steel between the columns. So, okay. For this one, we have here the shear diagram. And kung natuto kayo from TOS 1 and TOS 2, the value of the maximum factored moment in this area, in this width, will be located syempre at the zero shear. So, we have to find the location of the zero shear for this problem. So, for letter A, para mahanap natin yan, let's just make use of mode 3-2, wherein we'll use interpolation para mahanap natin yung location ng ating zero shear. So, for our x values, ito muna yung ating location, 0, and this will be 5.9. That is 5.6 plus 0.3. 0 and 5.9. So, for our y values, we have here 902 and negative 885.853. Negative 885.853. To get the value of the zero shear, location of the zero shear, we need to find a value of 0 x hat. So, mode 3-2, 0, 5.9, 902, negative 885.853. So, 0 at the location is 2.9 and that is in meters. So to get the maximum moment, M max, we will just get the area of this shear diagram, which is just triangular, no? So that is just 1/2 base times height, wherein our base is the location of the zero shear, which is 2.977, and height of 902. We will get an M max of 1,342.466, and that is in kilonewton meter. So ganyan na lang yun kadali, no? Yung iba sa inyo nagre-ratio in proportion ng manual, pero eto na, binibigyan ko kayo ng calculator technique kung gusto nyong gamitin. Pwede nyo rin siyang ma-utilize syempre for mga beams ninyo if hindi nyo pa alam or na-encounter yung ganitong type ng solution. So, after that, for letter B, hinanap naman sa atin is factored moment pero sa cantilever portion, which is just very easy. Tama ba? Kasi we already have the shear diagram. So, that's just, again, 1/2 base times height, wherein our base is the length of the cantilever portion, which is 1.2, and the height of the shear diagram, which is 363.634. So, let's just solve for that. For letter B, M max, pero again, for the cantilever portion, 0.5, 1.2 multiplied by 363.634. So the answer will be 218.1804, and that is in kilonewton meter. And that is the answer for letter B. So for letter C, the value of the nominal shear stress for one-way action of the footing. So, kung matatandaan ninyo, no, for one-way action, natatagpuan natin yung critical section within the distance D, no, from the face of the column. Pero for this one kasi, we have ilan faces na pwede natin makuha ang critical section, no? We have here this critical section, this one, and this one. Lahat yan critical section. Pero no, may tamang sagot dyan. Iisa lang yung pinaka-critical sa lahat, no? Which is this one. The most critical section in our shear diagram will be this one. Kasi no, kung titignan ninyo, if this one, dyan kayo mag-interpolate, may makukuha nyo yung value which is relatively smaller kapag nag-interpolate kayo this one or even this one. You can try checking on that, pero no, for almost all the problems in combined footing, the critical section for one-way action will be on this area. Yan. So, ganyan. So, actually pwede rin yan tanongin, no, what is the one-way action naman for the longitudinal section? Pwede rin ganyan, no, wherein this is D. Pero, let's skip that for now. Pero madali lang naman din kasi yun. Pero, with this one kasi meron tayong tatlong sections na kailangan i-consider. Pero tulad ng sabi ko, ito lang yung pinaka-kailangan yung i-consider. And that will be proved by this shear diagram. So, let's make use na lang ulit of this one, of this mode 3 to values. Kasi pwede naman natin siyang kuhain, no? Wherein this is D distance from 5.9, which is 0.710. So, for V1 way, that is just 5.9 minus 0.71. Tapos, para makuha naman natin, no, yung shear value, we need to get the y hat. And that is equal to negative 670.705 in kilonewtons. Well, actually, pwede nyo naman gawin, no? Kung gusto nyo ng conventional way, you can get PU minus QU multiplied by this area, which is just 0.5 plus 1.2 plus 0.71 multiplied by the width of 1.4. And I'm very sure pareho lang din yung makukuha ninyong value. Pero this one, Caltech lang yun, no? Para mas madali. Kasi this is already a shear diagram. So, pwede nyo na makuha yung shear value for the one way using this table. So, ganun pa rin, no? We will get tau one way is equal to V1 way divided by the reduction factor multiplied by BD. So that is 670.705 multiplied by 1,000 reduction factor of 0.75. And ang base natin, if this is a critical section, base natin syempre is si 1.4 or 1,400. And our effective depth given of 710. We will get a value for the one-way shear stress of 670.705, 1,000.75, 14710. A value of 0.899 or simply say 0.90 in MPa, and that is the answer for letter C. So last problem, we have here the value of the nominal shear stress for two-way action naman of the footing for 300 by 300 millimeter column. And as we all know, ito yung 300 millimeter by 300 millimeter column. And alam natin, no, that is located in this section. Pero ang problema natin, no, hindi na siya buo. Dati, ginagawa natin C plus D saka C plus D. Ang problema, yung isa natin dito, wala naman ng footing pad na kasama kasi nga flushed on the edge na siya, no? So, instead of C plus D, kailangan na lang natin is C plus D over 2 na lang. Kasi, kalahati na lang yan, no? Mahahati yung D natin. So, this is D over 2. Ito yung D over 2 na nawala. Pero for this longitudinal side, C plus D pa din. Wala namang nabago dyan. Ang may nabago lang is on this side. C plus D over 2. So, let's solve for V2A. Letter D. So, for V2A, we will get a value of PU minus QU. Pero ang area natin, C plus D over 2 multiplied by C plus D. Or 902 minus QU natin of 216.447. 216.447. C value natin, 0.3 plus 0.71 divided by 2, 0.3, 0.71. We will get a value of minus 216.447.
paki-guide lang si ma'am. Kasi may tanong po sa CV. Ayan, si Sir.
0.3 plus 0.71. We will get a V two-way for 758.809 and that is in kilonewtons. However, we are asked to determine the shear stress. So dapat tau two-way, which is just equal to V TW divided by the reduction factor multiplied by BOD. Okay. Next, we have a problem with BO naman. Dati, no, ang BO natin is equal to 4 times C plus D. Or kapag magkaiba, no, 2 times C plus D plus 2 times C plus D. C1 saka C2. Pero this one, no, sabi natin, BO is the critical perimeter na nasisira. Pero ang critical perimeter dito is itong tatlong sides na lang, no? Itong tatlong sides na lang. So, BO will just be equal to 2 times C plus D over 2 saka isang C plus D. So, let's compute for that. Wherein BO is equal to 2 times C plus D over 2 plus 2 times, plus C plus D. And that is equal to 2 times 0.3 plus 0.71 divided by 2 plus 0.3 plus 0.71. That is equal to 2.32 and that is in meters. So substituting our values, we will get 758.809 multiplied by 1,000 para maging newtons. Reduction factor will still be the same, 7.75. BO is 2320. Effective depth of 710. And we will get a value of 758.80. 809 multiplied by 1,710. We will get a tau two-way of 0.614 in MPa. And that is the answer for letter D. So I will leave situation number 3 for all of you para sa inyong seat work number 5 or 6 pala. Seat work number 6 to be passed next meeting. So we have here situation number 3, refer to the combined footing. So ito, no, binigay na kagad yung shear diagram. Pero binigay na yung shear diagram, binigay pa yung QU. Pinapasolve na lang yung mga values, no. How much is the punching shear stress at column B? Mandali na lang yun, no. That is PU minus QU. C times C plus D times squared na lang kasi pareho naman yun. C plus D. This one, critical wide beam shear stress. Wide beam, so syempre matatagpuan ulit yan dyan, no? Then, compute the number of 25mm bars within the length D from column B. So, length D, ito yun. So, kailangan nyo lang daw kuhain yung number of bars for the moment in this portion. So, that's it for the foundation engineering.